Okay, so let's get started on the EDSS project video presentation. So some background about my project is the application will be basically an automatic animal feeder. And the motivation I got for this project is, as a pet owner myself, some owners may not be able to feed their pets periodically. Hence, I empathize with these people. As such, my problem statement is how might we ensure pets have consistent access to food during times when their owners are busy or unavailable. So these are some of the peripherals that we used: GPIO, interrupts, timer, as well as ADC. So this is my system block diagram, which shows the main components I used in the project itself. So this is my flowchart, which shows how a user might interact with my automatic animal feeder. And this is the schematic diagram. Moving on to the Tinkercad demonstration. So as you can see here, it shows two servo motors, an LCD, Arduino, PIR sensor, buzzer, 3 buttons, light bulb, LED, and a photoresistor. So it'll be easier for me to start simulation and start explaining. So basically my first button is for toggling the different times, as you can see, 2, 3, 4, and the selecting and confirming is to accept that timer and feed the animal after that 2-hour, 3-hour, or 4-hour break. So if I press the toggle timer, it can show the different timing, but I'll show 2 hours right now. I can select and confirm. So what will happen after this is the feeding bowl servo will open up, and the buzzer as well as the LED will alert the animal so that they can eat. So it will count down from 2, 1, then the hatch will open. Then the buzzer and the LED will light up. Then it will be showing feeding time, and the PIR will basically show that the animal has eaten their food already. So animal fed, then basically 2 left will show that this is the amount of food left inside the automatic animal feeder before you need to refill it. So let's toggle the timer again. So let's say we want 3 hours. So we can select and confirm. I'm using seconds instead of hours because I cannot simulate in hours. So it will just be showing 3, 2, and 1. Okay, so basically the feeding bowl open again. Yep. Then the buzzer and LED will alert. Then we can feed the animal after they have fed. So 1 left. So another function is this LDR over here. So if it's very bright outside, the LED will switch off. But if it's very dark and your pets can't see, so the light will be used in that case. So for the last one, let's choose 2 hours. So the simulation time is shorter. So countdown in 2, 1. Okay, basically the next function will be for refilling of the food. So the feeding, okay. So we can just show that 0 left, then refilling. So now this is the time to refill. So what's next is basically the select and confirm will not work now. So if I try to use it, it will tell me to please refill it. So I cannot confirm until I refill the button. So let's try it now. So let's refill the food. So your second servo will open to simulate you putting back the food inside, and will refill it back to full. So if we press again, so it'll confirm, and yep, it'll work again. So that's basically how my project will work. So explaining more of the code over at the start here. So these are the libraries I'll be using. I'll be defining the clock speed to 16 megahertz for the CPU frequency. These are for my buttons and PIR, which will be useful in my program further on. And these are the variables which will help me with my different conditions. So this is the main code. So your DDRD over here is to initialize your different pins and enable them as well. So you're enabling your PR over here. Then we'll be setting up our timer 0, then setting it to a prescaler of 64, and so that it also is under the compare timer. Clear timer compare mode. Then we can enable the timer 0 interrupt. Then after which we can configure timer 1 to normal mode. Then we set the prescaler to 1024. After which we can set the we can set the pin change interrupt as well as the external interrupt for PB2 and PB3. Then we can initialize the LCD so that it can write into the LCD itself. This homepage is just to write the animal feed, which I'll explain later on. The ADs, you can initialize the ADC for the photoresistor as well. And this say will basically enable the global interrupt. This while here will just enable it to repeat the loop continuously and indefinitely. So this is my buzzer control, which will work together with the timer 1. This will be printing out as shown just now. So your animal feeder. Okay, so from 106 all the way to 150, this will be helping me with my servo for both of them. It will be just opening and closing. Your timer down, this will work together with the timer 0 interrupt to count down. So you're counting down in. Then your ADC initialization over here. Then from 180 all the way down to 247, it will help me write into the LCD itself and clear the different LCD page or write into it as well. So moving on to the different interrupts I have. So this is the pin change interrupt, and this will be helping me with the refilling button over here. So yep. So when the button uh, when the this is for the PR. So if it senses, then it would minus the different times the animal has been fed. Moving on to the external interrupts. This is for my button press as well as uh, button select. So the first as well as the second button. So you're toggling your 2, 3, 4 hours as well as selected as well as your please refill as shown just now. So your timer 0 interrupt now. This will work together with the count down just now, the timer down over here. Timer down. Yep, this will work together with this. And finally, the ADC interrupt, which will help me switch on the LED if it's below 20. This can be any value, but I'll just showing the proof of concept here. So it'll turn on the LED, I mean the light bulb over here. Yep, so thank you.